So right now we are discussing propagation of sound, right? So the particles of the medium do not move forward themselves, but the disturbance is carried forward. This disturbance is nothing but our wave. So this is what happens during propagation of sound in a medium. Okay. So hence sound can be visualized as a wave. Alright. So sound waves are characterized by the motion of particles in the medium and are called mechanical waves. Okay. So this is the definition of mechanical wave. In particular, you can say, okay, because sound waves are mechanical waves. Okay. The sound waves are characterized by the motion of particles in the medium and are called mechanical waves. Alright. Now, if we talk about air, since we talked about the media, so what kind of medium we are talking about? So let's first discuss air medium. Okay. What happens when a sound wave travels in air? Okay. So air is the most common medium, right? Medium through which sound travels. Okay. So when a vibrating object moves forward, it pushes and compresses the air in front of it. Okay. The air in front of it, creating a region of high pressure. Okay. Creating a what? Creating a region of high pressure. So just think about it. Air is the most common medium through which sound wave travels, right? So when a vibrating object moves forward, it pushes and compresses the air in front of it. So let's say this is our object, okay? If it travels in air, so let's say these are the air particles, okay? Or you can say air. So it will compress this air and then it expands it, okay? After that, yes or no? So where there is compressor, that compression of particles, that means there is high pressure, yes or no? And this is the low pressure region. Are you getting my point? High pressure and low pressure. So this is what happens, okay? So this region is called a compression, okay? This high pressure region is called compression. We denote it with C. This region is called compression. And this compression, after all, it will not stay as it is, right? It will start expanding, yes or no? Yeah. Because eventually pressure is gonna get lower. Am I right or wrong? Yeah. So this region is called a compression. This compression starts to move away from the vibrating object. And when the vibrating object moves backward, it will create a region of low pressure, okay? Which is called rarefaction. What it is called? Rarefaction. Rarefaction. Not fraction, rarefaction. Or faction. Yeah. So we'll have, let's say this is compression region, then there will be this rarefaction, then again compressed region, then again rarefaction, okay? And then again rarefaction, right? Yeah. So when this vibrating object moves backward, it creates rarefaction, right? Yeah. When the vibrating object moves backward, it creates a region of low pressure called rarefaction. Okay. Yeah. So as the object moves back and forth rapidly, a series of compression and rarefaction is created in the air. Okay, as you can see in this figure. This is, let's say, this is our vibrating object. So as it continues to move back and forth, okay, it will create compression and rarefaction regions. Okay. So as the object moves back and forth rapidly, a series of compressions and rarefactions is created in the air. Okay. Yeah. So these make the sound wave that propagates through the medium. Okay. Sound wave that propagates through the medium. Alright. So compression is the region of high pressure and rarefaction is the region of low pressure, right? So pressure is related to the number of particles of a medium in a given volume. Okay. So more density of the particles in the medium gives more pressure and vice versa. Okay. Thus, propagation of sound can be visualized as a propagation of density variation or pressure variation in the medium. Are you getting my point?